the same current. I'm writing 0, angle 0, that one, phase angle. Across the resistor, both are in phase. The applied voltage is Vm sine omega t minus phi. Across capacitor, the current leads the voltage by 90 degrees. So therefore here, shall we put Vc downward? Current leads voltage by 90 degrees. Since current is having 0 phase, so therefore voltage I'll make it minus 90 degree. And this applied VRMS. Where the red color? So let's write all the phasor diagram. So every problem I'm showing, no, it's like a numerical only. Every numerical you'll be doing this much only here. Let's take this one. So what is the phase angle of current? Current will be, or will show VR. Then this is VC. And applied voltage will be VRMS. This is a phase angle, and current also will be here. Let me complete this triangle. This will be VR, this will be VC, this will be VRMS. Then voltage triangle, VRMS square, as they are vectors, no, or phasors here. So VR square plus VC square. Let's apply Ohm's law across each and every element. Ohm's law across resistor. IRMS into R. Ohm's law across capacitor. Can you recollect yesterday we have done? IRMS into XC. What is XC? Capacitor reactance. And this should be equal to IRMS into Z. So Z square is equal to R square plus XC square. If I write in vector form, R plus minus JXC. If I draw the impedance triangle, it will be, this will be R, this is XC, and this is Z. Why minus J cap? Because you see XC is along, I think there's a convention, no? 0, J, minus J, J square. Any quantity along positive y-axis, it will have phase angle of 90 degree, and that 90 degree phase angle we show by J. A quantity is having minus 90 degree phase angle, just simply write minus J. So got no, in complex numbers you had plus I, minus I. So what do you mean by plus I? That particular physical quantity, a real quantity only, which is having a phase of 90 degree. What do you mean by A minus IB? I think high operator is having a phase angle of minus 90 degree. That B is a real quantity, not imaginary. At least now after getting this much of idea, please think in different way now. The complex numbers, what all actually you studied, the physical interpretation should be according to the requirement. The way it was, the complex numbers, why they are brought is for this purpose. This is about the voltage triangle. This is about impedance triangle. And then I want the phase angle of circuit. Tan phi should be equal to XC by R. What is XC? 1 by omega C. This is R. So by varying frequency, I can control the phase angle. Let's come for the power factor. What is power factor? R by mod of Z, which is equal to R square plus XC square. I think all these formulas you have to remember. This is the power factor. Now, what about the instantaneous power. Let's see that what happens to instantaneous power. The instantaneous power, we define V into I, which is equal to Vm sine omega t minus phi Im sine omega t. Look at now, current leads the applied voltage. So therefore, I'll give a name for this circuit. I'll call this as, I'll call it as lead circuit. RC circuit is called as a lead circuit here. So again, solving this, P instantaneous is equal to Vm Im sine omega t cos phi minus cos omega t sine phi sine omega t. Vm Im cos phi sine square omega t. Vm Im by 2 sine phi sine 2 omega t. So when you calculate the average power, so O will take that average power. Due to sine 2 omega t will be 0. Only due to sine square omega t will come. So what is the average value of sine square omega t will be 1 by 2. So what is the average value? Average power I think everything is in one place. P instantaneous dt by, this should be cut after solving, Vm Im by 2 cos phi. So this if I rewrite, Vrms Irms cos phi by 2. So 2 will not be there. Again, here also we'll get two powers, reactive power, even the same power triangles. We can similarly draw here. There's a resistive power, there's a reactive power, and this is the apparent power or power supplied by the source. So three triangles will get voltage triangle, impedance triangle, and power triangle. And again, the relationship will be PS square equal to PR square plus PX square. Vector sum of powers, vector sum of impedances, vector sum of the voltages. So what is the power factor again? Power factor depends on these quantities. By varying capacitance, can you control power S? By varying resistance, can you control power S? Power dissipation circuit. By varying frequency also, we can control the power dissipation. Now, again, what is P average? This P average is nothing but should be equal to RMS square R, no? Somewhere in the corner, I'll write it. Again, what is the wattless current? RMS sin phi here also. A component of current responsible for power. Other component is not responsible for power dissipation. So why one which is not, it's some applications that RMS sin phi is useful. Of course, we don't study that, but in designing of equipments, that is also very important. So this is called like a lead circuit and there's a lag circuit. So these are basics here. So just I think all the set of formulas, I think the total everything I'm bringing it at one place. So of all very important, because when you go for numerical, no, so finally you see that these equations are going to help you a lot. Then this writing KVL, then this power dissipation, average power, and who will dissipate power here? Only resistor will dissipate power. It's right, you write very clearly. Only resistor dissipates power in AC circuit. Finish over. What is the role of capacitor, inductor, then sir? Then why we are using it? To bring the desired phase angle between applied voltage and applied current. And now you can ask questions, sir. Okay, fine. Then what is the role of capacitor inductor? Why they have brought it? Okay, let's go for electrical equipment. What are electrical equipments we have? Costlier thing, air conditioner. Cost, I think nowadays it's going even up to 60,000. No? Then fan, air cooler, water pump, all electrical. Even you can see the television, then mixer, grinder, and you go to industries. I think some crores of rupees equipment will be there. No? It should be protected. Protected from what? From high voltages. So how do I can protect electrical equipment? If this is the electrical equipment is, so it should be protected from high voltages. So therefore, let me introduce one resistance. Electrical equipment will have resistance. I'll call that is RE. Then I'll see that R 10 times of RE. Is it okay? No. So this is, so therefore now if by chance if this voltage increases, tell me where the rising drop will be more. The rising drop will be more across the resistor than electrical equipment. And when you make RE code 10 RE, if this consumes 100 watt, what about how much this will consume? This will consume 1000 watt. Means if you get 100 rupees bill, in that what will happen? The 90 rupees is due to this and 10 rupees is due to electrical equipment. This is something very bad, no? And what is the purpose of this? To protect electrical equipment from exceeding voltages. So what is doing? It is giving protection, but at the cost of consuming 90% of electricity. If you get 1000 rupees bill, 100 rupees is what actually you have utilized. Remaining 900 rupees is got wasted here as a heat. So wastage of power is more here, no? Go back to voltage divider formula here also. What all applied voltage, there what when it will be more here than this particular thing. So therefore, if any voltage increases, first it will increase more here than this one. So first will burn out, this will get damaged. Okay, fine. I'm protecting electrical, but look at the bill. The electricity bill, what I get is something 90% of power I'm wasting here. Only 10% is what utilized by electrical equipment. For every 1000 rupees, 900 taken by this, only 100 rupees is utilized here. So this is a very bad design. Let me come for inductor. It's the same electrical equipment. Let me take help of inductor now. If I bring inductor, what is the thing? The inductor also will come with internal resistance. We can never get a coil. We can never get a coil which will not have resistance. So the inductor will also have some resistance. Then in turn, the inductor what happen will also consume some power. So there's also unwanted power. Here also unwanted power. Instead this, let me go for capacitor. If I take the capacitor, AC circuit fuse wire, even though when you use fuse wire, still problem will arise. So that I'll show it now. Now let there be capacitor. Then I'll make XC very much greater than RE or 10 times of RE. Fuse cannot withstand a very high currents, very high voltages. There's some limit is there. That's why the capacitor is brought here. So now here also I'll see that XL 10 times of RE, but because of smaller power dissipation. What about capacitor? Purely it will not dissipate any power, no? And it will not dissipate any power, and it is also giving protection. If at all high voltage comes, first capacitor will burn out. Once capacitor burn out, so okay, no, the electrical equipment is safe. Will it dissipate any power consumed? Capacitor will not dissipate power. Unwanted power because of small r. and there'll be flux linking, flux leakage will be there, but we don't have any such thing from capacitor here. That's why you take the air conditioner, inside what happen, condenser will be there, fan, condenser, it's called as a condenser. Why it is brought? Only to protect electrical equipment from high voltages. If high voltage comes inside the fan, like this, you can see a plastic one, a tube, a small box will be there. If you want to open it, dome, no? Switch off all power, then open this dome. There you can see this. It will be size like almost the thumb size. It will be there. In air conditioner, the cost will be around 200 rupees. In the fan, the cost will be around 40 rupees. Tube light also, earlier tube lights it used to have. Like that, you take any electrical equipment, capacitor is brought here. What is the purpose of that? To protect the electrical equipment. If high voltages comes, first capacitor will burn out. And it will not dissipate power. So what is the role of capacitor? It will do its duty without expenditure of energy. Resistor inductor fails in that aspect. So like this, the capacitor is introduced here. Got that? So they may test you general passages related to this. So what capacitor? Capacitor protects equipment and will not dissipate power. Inductor open will protect equipment, will dissipate power. Resistor R protects and also dissipates power. So which one I should pick up? So definitely the capacitor. This is not suggestible. Worst case, okay, you can go for it. And this is